As you know, last week we learned the interrupt structure, and the last topic for this lecture, peripheral units for 89S 8253. In here we have an important topic, which is serial communication. But I want to say some another peripheral units for a microcontroller. In here we have some of them. 8051 based microcontroller. Today we have a lot of features. Some of them is given here for the serial communication, high speed analog input to the digital converter, analog output, which is DAC, digital analog converter, pulse width modulation for the DC-DC converter, or a DC motor, for example. Some extra memory, long life, double DPTR, high speed communication units, besides the UART, I2C, SPI and CAN, and things like that. Watchdog timer to prevent some problem on the industry, power supply monitor, power down, and ISP in system programming. Yes, let's start the serial channel communication. As you know, we need a communication between humans, right? And the same way, if you use a microcontroller, this microcontroller should get some communicate with another microcontroller or computers. At least one time we need a communication between the computer and microcontroller to load any program to the microcontroller. Okay, because of this we have to know serial communication. So we need to communicate with the computer and microcontroller to upload any machine codes to the microcontroller. Serial data communication can be performed as simplex, duplex, or simultaneous full duplex communication. What does it mean? In the simplex communication, we have a transmitter and we have a receiver, and we don't have to send any information from the receiver to the transmitter in this type. Okay. For the duplex communication, as you see, we have a transmitter, and also this transmitter can be a receiver. Okay, and as like that, the other microcomputer or microcontroller can be a receiver or also a transmitter. If you want to get a communication between two microcontrollers, as you see here, this is the minimum connection between them. This is the first microcontroller and second one. We have some pins to send information and get information, which is port 3.0 and port 3.1. Port 3.0 is received data, port 3.1 transmitted data. So if you send any information from microcontroller 1 to microcontroller 2, we will use port 3.1 to send this information. For the microcontroller 2, this information will be obtained from the microcontroller 1. How? We have to use, of course, receiver input, which is port 3.0 for the microcontroller 2. Vice versa, if you send any information from the microcontroller 2 to the microcontroller 1, we will use transmitter pin or the microcontroller 2, and we have to use receiver pin or the microcontroller 1. Also, for any operation, as you know, we have to use common ground. So in here, the ground pin will be as like that. As I said before, some pins have extra specification. Yes, here we said before we have some extra specification. Port 3.0 is also used receiving a data, and port 3.1 can be used as a transmitter. Okay, you can think as external 0 and external 1 input. This is reserved pin. You can use this pin for the communication between the physical world and microcontroller, and also port 3.0 and port 3.1 is used for the serial communication between the microprocessor. If you want to use a communication between the microcontroller with the computer, we have to use also an integrated circuit which is called as MAX 232. Why? For the logic level, the logic levels for the microcontroller are 0 to 5 volt. But for the computer, it is plus and minus 12 volt. Okay, logic levels are plus and minus 12 volts for the computer, but microcontroller, as you know, we used 0 to 3.3 or 0 to 5 volts as a logic levels. So if you want to communicate microcontroller with the computer, we have to use a conversion between them, and MAX 232 is used for this purpose. For the computer, this is the RS-232 protocol, as you know. The second, third, and fifth bit of this connection is receiving data, transmitting data, and ground pin. And as you see here, receiving data pin is connected to the transmitted data pin of the microcontroller through the MAX 232. And vice versa, transmitted data pin is connected to the receiving data pin through the MAX 232. For the standard 8051 architecture, we have two SFRs for the UART serial communication, which are SBUF and SCON. Yes, SCON register is used for the settings of the serial communication, and SBUF is the temporary register for the information. If you send any information, you have to write it before the SBUF register. And if you want to get any information, you have to use SBUF register before. What about the SCON register? SCON register is a setting register for the UART, and it can be bit-based addressable. It's important, as you know. Let's examine it. SM0 and SM1 is a mode selection bits of the SCON. If both of them is 0, mod 0, which is sleep logger, baud rate constant, oscillation frequency over by 12, which is baud rate for us. What is mean baud rate? Is there any student to know baud rate? If I say you the units or the baud rate, you can easily understand it. It is bit per second. So maybe we can say it is the communication speed, right? What about the mod 1? For the mod 1, SM0 is 0 and SM1 is 1. This mode is used usually for the serial communication. 8-bit UART baud rate can be set with TH1. It is the high byte of the timer counter 1. Okay? High byte of the TC1. Yes, if we use mode 2, it is 9-bit UART baud rate constant, which is oscillation frequency over by 32 or by 16. What about the last one, mode 3, 1 and 1, 9-bit UART again, baud rate can be set with TH1. Okay, I will repeat again. This is the most important mode for the serial communication. Okay, we will use it. What about the others? SM2 here, it is not important for us for now. If we need, I will explain you. And the fourth bit of the SCON ran. When this bit is set, data accretion from serial channel is authorized. When cleared, serial data reception stops. What about the TB8? This bit is 9th bit of the data transmitted second and third mode, so we will not use for now. RB8 again used for the second and third bit. What about TI and RI? TI means transmit interrupt or receive interrupt. Okay, so we can use as flags. That's our flags for the transmitting or receiving a data. But please remember that the name of TI is transmit interrupt, but we can also use this flag with the polling mode. Okay, we can use polling mode. Okay, this bit is set by the hardware when serial data transmission is completed. It needs to be cleared with software before sending a new data. Please don't forget it. We have a bit which is 4th bit of the SCON. You have to set this bit if you want to get any information from somewhere. Okay. If it is 0, you cannot get any information from the other microcontroller or microprocessor. Yes, what about RI? This bit is set by the hardware when serial data reception is completed. After reading the SBUF data, it must be cleared with software for new data retrieval. We can set the baud rate by using the TH1. How? For our microcontroller, we have a formula. Actually, we cannot say for our microcontroller, it is the general formula for the baud rate. For, of course, 8051 based microcontroller. Okay, what is this? 2 to power S mode, which is 7th bit of the P-con register, SFR. F machine cycle, this is the frequency of the machine cycle, over by 32 times with 256 minus th1 bit per second. Okay, for the baud rate, of course, we have some standards. Okay, for example, if you see the computer, you can see 9600 bit per second. It can be until bit per second, sorry, bit per second. It can be until 115,200 bit per second, and it can be continuous like that. But general usage about the baud rate 9600 bit per second. What is the frequency of the machine cycle? It is for standard 8051. As you know, this is the oscillator frequency over by 12. Okay, and it is the same with our microcontroller. So we can calculate by using here F OCS over by 12. Here we have an important note. If we use a serial communication and TH1 for the setting baud rate, mode 2 auto reload, sorry, here reload mode should be selected for the TC1. We have to select mode 2 for the TC1. Maybe we can remember it. Yes, here mode 2 8-bit auto reload timer or counter mode. Of course, we will use timer mode. For example, if you want to set baud rate as 9600 bit per second, what should we do? Or the TH1. Let's calculate it now. If we use S mode as 0, which is 7th bit of the P-con, maybe we can see next. And if we use 10 megahertz oscillator frequency or crystal frequency, what we get here, after some arrangement, this difference should be approximately 2.71 and 3. So maybe we can get approximately for the TH1, approximately of course, 253 decimal, which is FD hex in the hexadecimal number system. But as you see here, we have an approximation, and it is so important for the serial communication. Why? In here, we accept, sorry, it is not 3, it is 253 decimal. If we use this value for the TH1 and if we calculate again baud rate, we can get approximately this value. But actually we want 9600 bit per second. So here we have so large difference between the communication speed. Okay. So it can be an error for the serial communication because of the move away from this value. To avoid this kind of problem, we have to use some standard crystal frequency such as 11.0592 MHz. If we use this crystal frequency, what we get? Let's examine it. In here, as you see, we can get an exact value. TH1 should be 253 decimal, which is FT hex. If you use this kind of crystal frequency, we will not have any problem for the serial communication. But it is possible to see some problems if you use 10 MHz oscillator frequency, because there is an approximation and the difference between the real one is so high. We have also another important issue here, the settings on both sides. What is both sides? We have a receiver and also a transmitter, or receiver transmitter and also another receiver transmitter. So the settings which are baud rate, communication mode and etc. on both sides must be the same so that two devices can communicate correctly over the serial channel. Maybe you can think as I can speak very quickly, but you cannot understand so quickly. It's about the communication speed, right? So I have to speak according to your understanding speed. Okay? You can dismiss some words if someone speaks very quickly. You can think as like that. If you want to get a similarity between the serial communication, what can you say about the TI and RI bits according to the human? We want to get a similarity such as clock pulses, hertz bits. Okay, if you want to get another similarity between human and microcontroller, what can you say about the TI bits, for example? Please remember that TI is transmitting interrupt. We can say it can be thought as a mode, right? Transmitting interrupt, it can be thought as mode. What about the RI? So we have to use the same baud rate setting for all microcontroller for the serial communication. Commonly used mode for UART serial communication is 8-bit adjustable baud rate mode with TH1. Since SM2, TB8 and RB8 bits are not used in this mode, so their values are set to 0. Here we have an example. Write 8051 assembly program code that sent feed data to the screen via serial communication from a microcontroller. Okay, what can you say about this type of serial communication? It is simplex, duplex, or simultaneously full duplex. What can you say? It is simplex. Why? We have an information and we will send it to the screen from the microcontroller. So information flowing is only one direction. So we can easily say this is simplex serial communication. Let's examine the program codes here. This is the header file which is to be used in the application. Origin 00 hex, SRAM X, and we'll start from this line. T mode is set as here, as you see, it's about TC1 and TC0. We will not use TC0. For the setting of the baud rate, we will use TC1. This is 8-bit auto reload, timer, and software start stop setting, as you see, 0 0 1 0. Mode 2, gate is 0, software start stop. This pin is about timer, of course you know. Yes, what is more, TL1 is FD hex and TH1 is FD hex. Why? As you see here, for using this baud rate, we have to set TH1 as FD hex. Okay. What about TL1? Why we use TL1? Also, what do you think? It's about the auto reload mode, of course. In the auto reload mode, for the first operation, as you know, TL1 should be have also initial values. Okay, because of this, TL1 is loaded with this value. Yes, here, as you see, for the first operation, we don't have any overflow, so we need to load initial values to the TL register. Okay, for the first time. What about more? Yes, here SCON is 01010000. Let's examine it in detail. Yes, SM0 should be 0, SM1 should be 1 for the mode 1. If you use mode 1, as I said before, it should be 0, 0 and 0. What about more? If you get any information from somewhere, it should be set. But for this question, of course you can use also 0 because we don't get any information from somewhere. Okay, only we will send an information to the screen. What about TI and RI? They are flags. So it's about the hardware. If it is set from the hardware, we will clear, but we cannot set this flags. So it should be 0 and 0. So here the SCON is 0, 1, 0, 1, 0, 0, 0, 0. It should be 1 or 0. Okay. Set bit TR1 means, because we will use TR1, so we have to set it. It is started. And then SBUF is temporary register for the serial communication. If you want to send any information, first of all you have to send it to the SBUF register. And then we will use in here polling mode. Jump if not bit TI, transmitted interrupt is 0, wait this line. If it is 1, clear the TI, and here we have an endless loop. If you want to send again and again the same information, you can use here X2 label. Okay, new data from the SBUF and wait for the transmitting operation and clear it and turn back to this line. And here finish the program. Please remember that TI and RI are also a source for the interrupt. Maybe I can show you. Yes, here we have a serial communication, RI and TI. They are interrupt sources for the serial communication. If you want to use interrupt structure for the serial communication, you have to set enable serial and enable all. If you don't want to set any priority, you don't need to use here. That's all.